We're now going to move into a more complex rational function. So what if we were given a function that looked like this, where we had a binomial on the top and a binomial on the bottom. So both the numerator and the denominator each have a binomial, and they each have a term that has x in them. Well, how do we graph these now? Well, we can't use the translations when we have a binomial on the numerator and the denominator. It just doesn't work. So what we're going to do is that we have a formula for finding both the vertical and the horizontal asymptotes. So our vertical asymptote is x equals negative d all over c. So you have to find the d and the c and make a fraction. And then we have our horizontal asymptote. And our horizontal asymptote is y equals a divided by c. So you get the a divided by c. So we'll get our two asymptotes, and they'll tell us about generally where our hyperbola is supposed to go. But after that, we have to end up using an xy table to figure out where our hyperbolas actually are. So let's do some practice problems. So our first practice problem, we need to graph this function, and it has a binomial in both the numerator and the denominator. So we have to use our equations that give us both the vertical asymptote, and the equation for the vertical asymptote is x equals negative d all over c. And then we're going to have to use the equation for the horizontal asymptote, and his equation was y equals a over c. So we obviously have to come in here and we have to find our ABCDs. So my A is the 2, my B is the 1. So A is always the coefficient of the numerator's binomial. The B is always the constant of the numerator's binomial. C is the coefficient in the denominator, and D is the constant in the denominator. So I've got my ABCs. So my vertical asymptote is going to be a negative, and I need to figure out whatever D is, which just happens to be a negative 3. So I have a negative, negative 3, and C is 1. So negative, negative 3 is a positive 3 over 1, which tells me that my vertical asymptote, 3 divided by 1, is 3. My horizontal asymptote, my A was 2, and my C was 1. So I have a horizontal asymptote of y equals 2. So this is where we're going to stop at the moment, and we need to graph what we know. So we know currently our asymptote. So here's my piece of graph paper. And I know that my vertical asymptote is at x equals 3. So here's my x-axis. Here's x equals 3. So here is my vertical asymptote at x equals 3. And then I got to graph my horizontal asymptote, and that was y equals 2. So here's the y-axis, and there's 2. So here's y equals 2. Now it's going to figure out where my hyperbola is supposed to go. So to do that, we have to do an xy table. So we're going to come up here and we're going to do our xy table. Now we know that hyperbolas are diagonal from one another. So we just need to figure out which one of these 4 quadrants our hyperbola is going to be, and then we can use that to find his partner. And so I'm just going to come over here and I'm going to test 0, 1, and 2. Just because those numbers are small, they're easy, and they're all within one quadrant, so I can see if it's in there or not. So 0, 1, and 2. So if I plug 0 into this equation, I end up getting a negative 1/3, which is the same as negative 0.33. If I plug 1 into this equation, I end up getting a negative 3/2, which is the same as negative 1.5. If I plug 2 into this equation, I end up getting negative 5. So plotting these coordinate points, I go over 0, but I go down negative 1/3. There you go. Over 1, and I go down 1.5. And then over 2, and I go down 5. I know that it needs to be trapped within these asymptotes, and my 3 points are right here. So I know that my first hyperbola is going to be right here. And if he's here, his partner has to be diagonal, which meant his partner is going to be somewhere over here, and I'm just going to guesstimate draw it. And there's a hyperbola. So now we just have to answer a couple of questions. We already know what our asymptotes are. So now I need to figure out what is my domain, what is my range. Domain talks about x's. We know on hyperbolas, our domain is always going to be all real numbers, but there is a specific x that we are never allowed to use, and it's the x asymptote. Range, we know it's also always all real numbers, but there's a specific y, it's the y asymptote that we're never allowed to use. So for our next practice problem, again, we have a binomial on both the numerator and the denominator. So our translations don't necessarily work. So we need to find our ABCs and Ds, so ABCDs. A is always the coefficient, B is the constant, C is the coefficient, D is the constant. And we're going to use these to find both our vertical asymptote and our horizontal asymptote. And our vertical asymptote is the equation x equals a negative d over c. Our horizontal asymptote is the equation y equals a over c. So for my vertical asymptote, I need a negative. Now I got to go find d. D is a 3. All over my c is a 1. So my vertical asymptote is a negative 3, because negative 3 divided by 1 is negative 3. Horizontal asymptote, my a is a 1, and my c is also a 1. 1 divided by 1 is 1, so I know my horizontal asymptote is a 1. So we're going to start by at least graphing these first. So here's my graph paper. My vertical asymptote was at x being negative 3. So here's my x-axis. Here's the negative 3. So here's my vertical asymptote. My horizontal asymptote was at y equals 1. So here's my y-axis. There's the 1. So here is my horizontal asymptote. So now I just need to figure out which of these 4 quadrants one of my hyperbolas is in. So we're going to do the xy table. Negative 3 was used. Let's just go over here and just test these couple of 3 over here. So I'm going to test 0, negative 1, and negative 2 because they're just right here and none of the asymptotes cross it. So there's nice ones to use. So if I plug 0 into this equation, I end up getting a negative 1/3, which is the same as negative 0.33. If I type negative 1 into this equation, I get negative 1. If I type negative 2 into this equation, I end up getting a negative 3. So 0 was at negative 1/3, which is here. Negative 1 was at negative 1. And negative 2 was at negative 3. So I know that the hyperbola is in this quadrant. It has to be trapped by these asymptotes. So here is my hyperbola. And I know hyperbolas are diagonal each other. And we're just going to guesstimate where his partner is. Now we need to find our domain. We need to find our range. And I need you to explicitly say which quadrant we are using. So domain is always going to be all real numbers except for the x value that has our asymptote, because we can never use that value of x. Our range is also all real numbers except for you cannot use the asymptote y value. And quadrants, this is quadrant 1. There is nothing up here. Oh, he does. He slips right up in there. So we have somebody in quadrant 1. We do have somebody up here in quadrant 2. He is over here in quadrant 3. And he is actually over here, very small right there. He is actually in quadrant 4. So this problem actually exists in all of our quadrants. So our next example, we need to graph the function, and this is a rational function that has both a binomial in the numerator and the denominator. So it doesn't really work with our standard form. So we're going to have to identify our ABCDs so that we can find our vertical asymptote as well as our horizontal asymptote. And because the problem has a binomial in the numerator, we're going to end up having to do an XY table to figure out where our hyperbolas actually are. So let's first find our A. It's the coefficient in the numerator. The B is the constant. C is the coefficient in the denominator. D is always the constant. So our vertical asymptote is the equation x equals negative d all over c. So I have negative, d was a negative 2, so I have a negative, negative 2. All over c is a 4. Negative, negative 2 is a positive 2, so this is 2 over 4. So my vertical asymptote is the fraction 1/2, because 2 divided by 4 is 1/2. My horizontal asymptote, that is the equation y equals a divided by c, and a is a 2, c is 4. So again, 2 divided by 4 is 1/2. So my horizontal asymptote is also 1/2. So we need to get our graph paper, and we're going to need to graph this. So I need my vertical asymptote to be at x at a half. So here's my x-axis. If that's 1, that meant 1/2 is going to be right here, as best as I can. My horizontal asymptote is at y equals 1/2. So here's my y-axis. The 1/2 is about right there. So here's me at 1/2. And now I just got to figure out which quadrants I need to draw it in. So I am going to come over here and I'm going to test 1, 2, 3 because they're all existing over on one side of the asymptotes. So 1, 2, 3. If I plug 1 into this function, I end up getting the fraction 3/2, or that's 1.5. If I plug 2 into this, I end up getting the fraction 5/6, which is the same as 0.833. If I plug 3 into this fraction, I end up getting the fraction 7/10, which is the same as 0.7. So if I were to graph these, that's 1, 1.5, 2, it's a little less than 1, 3, it's a little less than. We're getting closer and closer to the 1/2 asymptotes. So I see that it's going to exist over here compared to these asymptotes. And then his partner is going to be on the opposite side over here because they're diagonal from each other. And now I just need to find my domain and I just need to find my range. Domain is always going to be all real numbers except for the 1x value that your asymptote is at, so I cannot be at 1/2. My range is also going to be all real numbers except for the one number my asymptote is at. That's it. So our last practice problem today, we need to graph this as a rational function that has both a binomial in the numerator and the denominator. If it has a binomial in both the numerator and the denominator, you have to use these equations to figure out your asymptotes, and then you have to figure out a table to find where your other hyperbolas actually are. So a is always the coefficient in the numerator, and b is always the constant in the numerator. C is the coefficient in the denominator, d is always the constant in the denominator. My vertical asymptote is the equation x equals negative d over c. So here's my negative. Now I need a d, which is a -1, all over my c, which is also a -1. Negative, -1 is a +1, but the denominator is still a -1. So my x is supposed to be 1 divided by -1 is a -1. I need a divided by c. A is a -3. C is a -1. -3 divided by -1 is a +3. So my horizontal asymptote is y equals 3. So we're going to get our graph paper so we can graph this problem. My vertical asymptote is where x is -1. So x-axis, there's my -1. So here is my vertical asymptote. My horizontal asymptote's on the y, so here's my y, and it's at 3, so here's 3, so here's my y at 3. And now I just need to figure out where it's going to live. I'm just going to randomly test 3 numbers, and since 3 numbers exist over here on this side, I'm just going to pick 0, 1, and 2. You could honestly pick any numbers you want. So if I plug 0 into this formula, I get -2. If I plug 1 into this function, I get 1/2, which is the same as 0.5. If I plug 2 into this function, I get 4/3, which is the same as 1.33. So graphing this, 0 is at -2. The minute I put that 1 point, I know it exists on this side of these asymptotes, so I can just draw it over here, but I want a general idea of what it really looks like. And then 2 is 1.3. So here is 3 points that kind of tell me the general direction. If he's over here, I know it's on the opposite side, so he exists over here. And then I just need to say my domain and my range. Domain is always going to be all real numbers except for the 1x value that the asymptote is at because we never use it. The range is also all real numbers except for the one asymptote value that we're not allowed to use. And that's it.